Alright, so today we are going to do optimization with a box with cutout edges and distance from a function to a point. So the first problem is a sheet of cardboard 10 feet by 12 feet will be made into a box by cutting equal sized squares from each corner and folding up the four edges. What will be the dimensions of the box with the largest volume? Okay, so we're going to do this one first, but I'm going to do an example. I'm going to make it 10 feet by 20 feet. Okay, so here we go. I need my weapon of choice is a pencil, not a pen. Alright, so for this problem, a box with cutout edges. Well, not a box. It's a cardboard. A piece of cardboard with cutout edges, and so it looks like, if I can zoom in a little bit. So we make a model first. Always need your geometrical model. So we lay a piece of cardboard flat. It's 10 by 20. Okay, and then we cut out these. We're going to cut out these squares, these edges. Let's make that distance x and that distance x. And that'll be x and that'll be x. And so will these. So we cut these out, and then we're going to fold them up too to make a box. Okay? And of course that one's x and x too. Okay? So what we need to understand before we go too much further is this side right here is 20 long. Take away this x and take away this x. Alright? So the interior right here, let's draw the picture of it standing up now. When we fold that up, it'll look something like this. Okay. Alright. So this distance right here is now this distance right here. Okay. This distance right here is now this distance right here. And this distance is 20. Take away these two x's. Alright. And now this distance right here is 10. Take away these two x's. And this distance right here, well, that's these x's. These x's fold up to make a height, so the height is x. Okay? So what we want to do here is we want to maximize volume. Of this box. So what's the volume equation? Volume is big base times height of any prism whatsoever. So this base, the prism, the base, the area of the base times the height. So we do the area of the base. The area of the base is equal to length times width, where that's the length and that's the width, or however you like saying it. So we're going to make this a little nicer. Oh, I'm sorry. Ooh, I lost a eraser there. Okay. So this is going to end up being 200 minus 20x minus 40x, and that last one is plus 4x squared. I'm going to switch it around and combine like terms. 4x squared minus 60x plus 200. Okay, so that's my big base of this container here. My big base is 4x squared minus 60x plus 200. But you see, we also have a height to consider. The height is actually x. Alright, that's why it's important to do a good model. And we're maximizing volume. This is our volume equation. We call this our primary equation. Let's simplify this some more. Alright, so my volume is 4x cubed minus 60x squared plus 200x. Notice you have 1, 2 variables. We're ready to optimize this equation. Now I'm going to go ahead and pause if I can, and this video will start back here in a second when I get some more time to complete it. Alright, bye.